Okay, get this. What if you could get a 9-year warning before dementia sets in? No, that's not a line from some sci-fi movie. It is the very real promise of a revolutionary new AI test. And today, we're going to break down exactly how it works, what the experts are really saying, and what this all means for the future of our brain health.
Just think about that for a second. A warning signal, a little glimpse into the future of your own mind, years before you'd ever notice anything was wrong. This isn't just some hypothetical question anymore. It's a real possibility being explored right now by some absolutely incredible new research.
So, to really get why this new research is so important, we've got to first understand the huge problem we have with diagnosing dementia right now. And really, it all just comes down to one thing: timing. You see, the heartbreaking reality for most people is that by the time they actually get a dementia diagnosis, these really significant, irreversible changes have already happened in the brain. It's kind of like trying to put out a fire after the house is already burned down. And that is the core dilemma that scientists are just so desperate to solve. But now, a brand new study from Queen Mary University of London is offering what could be a total game changer. It's a way to see the smoke, long before the fire even starts. So what they've done is they've combined these special brain scans called functional MRIs or fMRIs with a really sophisticated machine learning model. Now, fMRIs basically map out brain activity by tracking blood flow. And the key here is that this AI isn't just looking at the brain's physical structure. No, it's analyzing how different parts of the brain are communicating with each other in real time. And what it found? Well, it's pretty staggering. This model, it was able to pick up on these really subtle, hidden signs of dementia up to 9 years before someone would normally get a clinical diagnosis. Just let that sink in for a minute. That is an enormous, almost decade-long head start. And we're not talking about a lucky guess here. The study reports the model is a stunning 82% accurate. So what we're looking at is a potential tool that's not just incredibly early, but it's also remarkably precise. So how on earth does it actually do it?
Well, the secret, it turns out, isn't in asking the brain to do some complicated task. Nope. It's all about observing the brain during its quietest moments, when it looks like it's doing nothing at all.
This is where we get into something really fascinating called the default mode network, or DMN for short. The absolute best way to think about it is like a car's engine when it's idling. It's that network of brain regions that's just kind of humming along in the background when you're daydreaming or letting your mind wander. And what scientists have figured out is that the health of this idle state can actually reveal a ton about the brain's overall condition. So the process itself is actually pretty straightforward. First, they scan a person's brain while they're just completely at rest. Then, the AI gets to work, sifting through all that data, looking at how the different parts of that default mode network are talking to each other. And finally, it learns to spot a very specific pattern, a kind of breakdown in that communication. The lead researcher calls it a dementia-like pattern. And here's what makes this so compelling. The model didn't just spot some random pattern. The specific changes it flagged actually lined up with well-known risk factors for Alzheimer's, things like a person's genetics or even social isolation. This adds this really powerful layer of validation. It suggests the AI is really onto something big here. Okay, so a study this groundbreaking is obviously going to bring up some big questions about, its real-world use. So let's pump the brakes a little and get a balanced view from some experts who weren't actually involved in the research. So on the one hand, the promise is just huge. This could totally revolutionize how we find people for clinical trials for new drugs. And it could help us understand the disease's earliest stages like never before. But on the other hand, there are some pretty serious hurdles. These fMRI scans can be tricky to reproduce consistently, the group they studied wasn't very diverse, and the model looks at all-cause dementia, not necessarily specific types. Let's dig into those limitations a bit more. A neurologist, Dr. Clifford Siegel, he points out that unlike a regular MRI, two different experts can look at the exact same fMRI scan and come to different conclusions. That's a problem. And Dr. Claire Sexton from the Alzheimer's Association, she highlights that the study group was mostly white and actually healthier than the general population. So we just don't know if these results are going to hold up for everyone. But really, this quote from Dr. Siegel gets to the most sobering part of this whole story. He says, unfortunately, in the year 2024, we do not have any neuroprotective medications to be used at this time. And that raises a huge practical question, right? Even if we can predict dementia 9 years early, what do we actually do with that information? Because right now, we just don't have any proven medications that can stop or reverse the disease that early on.
So, if it's not ready for your doctor's office and there's no early-stage cure, what's the real value of this incredible technology, like today?
Well, for now, we have to see this for exactly what it is. It's a phenomenally powerful research tool. It is not ready to be used as a clinical diagnostic test, at least not yet. But its value inside the laboratory, that is absolutely undeniable.
And this is the monumental leap forward. The study's own author, Professor Charles Marshall, he explains that this test could be used to find the absolute perfect candidates for clinical trials. Think about it. By testing new drugs on people in the disease's earliest hidden stages, we give ourselves a much, much better shot at finally finding a treatment that actually works.
So, no, this AI isn't a cure today, but it might be something almost as valuable. It's a map. It gives researchers a way to navigate the disease's darkest, earliest pathways. And by lighting the way forward, well, it may just be the key that finally helps us unlock a cure for tomorrow.